Welcome to the peaceful space of sleep-friendly science, where tonight we'll drift among the cosmic dust clouds and witness the silent, powerful force that sculpts the heavens themselves. Have you ever gazed up at the night sky and wondered how it all came to be? We will explore the gentle, persistent pull of gravity, the cosmic sculptor that gathers shimmering dust into stellar nurseries and arranges countless suns into breathtaking galaxies. It's a slow, silent dance across the cosmos. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Universal Whisper of Gravity. Imagine, if you will, a time before time as we know it. A time before the first star had ever blinked into existence, before the first galaxy had ever begun its slow, celestial swirl. Journey back with me not to a moment of cosmic violence or a brilliant explosion, but to the profound and patient silence that followed the great unfurling of our universe. Here, in this nascent cosmos, there's no up or down, no grand celestial landmarks to guide you. There is only a vast, dark, and cooling expanse. The universe is a near-perfectly smooth ocean of potential filled with the simplest things imaginable, a diffuse mist of hydrogen atoms with a gentle scattering of helium. They are the first letters of a cosmic alphabet not yet formed into words or stories. They drift alone, each one an island in the immense, quiet dark, separated by gulfs of space that are almost beyond our comprehension. The temperature of everything, everywhere, is slowly, steadily falling like the embers of a fire that has warmed an entire world, now fading into a deep and lasting chill. In this place of profound simplicity, you might think that nothing could ever happen. That these lonely atoms would drift for eternity, unaware of one another, lost in the endless night. But there is something else here. It is not a thing you can see or touch. It is not a sound you can hear. But if it were, it would be the lowest, softest hum imaginable, a note held since the very first moment of existence. It is a presence, a law woven into the very fabric of being. We call it gravity. But let us, for tonight, set aside the word force. That word implies a push, a pull, a struggle. Here, in the beginning, gravity is not a force. It is a memory. It is the universe's own deep, abiding memory of a time when everything was one. Before the great expansion, all that isovery atom in your body, every star in the sky, every grain of dust in the interstellar void is compressed into a single, infinitesimal point of impossible unity. And now, scattered across the vastness, the universe remembers. Gravity is this memory in action. It is a gentle, patient, and unwavering invitation for things to come together again. Feel it around you now in this primordial darkness. It is not a command shouted across the void. It is a whisper, an almost imperceptible suggestion. Each atom of hydrogen in its solitude exerts a tiny, infinitesimal call to every other atom. And each atom, in turn, feels the whisper of all the others. For now, the call is too faint to matter. The outward rush of the universe's expansion is still the dominant song, carrying everything further and further apart. The atoms are like ships sailing away from a common shore, their farewells lost on the wind. But gravity is patient. It does not tire. It does not fade. It is a constant. While the expansion of space carries things apart on the grandest of scales, in smaller, local neighborhoods, the whisper of gravity persists. Imagine you are floating amongst these atoms. You see one, a perfect, simple sphere of a single proton and a single electron drifting in the velvet black. Far away, almost too far to measure, is another. They are on separate paths, destined to never meet. But the whisper is there. The memory of unity is between them. It subtly, gently alters the fabric of space-time itself. It is as if the very presence of each atom creates a slight, gentle depression in the cosmic fabric, a shallow valley of being. And the other atom, in its journey, feels the faintest, softest slope. It is not a tug. It is a guidance. Its path deviates, ever so slightly, by a measure smaller than its own diameter, over 1,000 years. It is a change so small as to be almost meaningless. But what is true for 2 atoms is true for 1 trillion. And what is true for 1 trillion is true for 1 trillion more. Now, imagine a region of this cosmic ocean that, by pure chance, is just a fraction of a percent denser than the region next to it. It has just a few more of these lonely atoms per cubic light-year. In this slightly denser patch, the whisper is not louder, but it is more choral. The individual whispers of countless atoms combine. Their tiny, individual valleys in spacetime overlap and merge, creating a broader, slightly deeper basin of influence. This is the beginning of everything. It is not a dramatic event. It is the slowest, most patient gathering in the history of the universe. An atom drifting near the edge of the slightly denser region feels the collective, gentle suggestion of all the atoms within. Its path bends not away but inward. Over 1,000,000 years, it may drift a few feet closer to the center of the patch than it would have otherwise. Another atom joins it, then another. They are not falling or crashing, they are simply arriving. They are answering a call that has been echoing since the beginning of time. This process is the embodiment of peace. It is a testament to the power of the small, the persistent, the gentle. The universe is not in a hurry. It has all the time in the world. It is content to let this quiet, gravitational sorting take place over eons, a slow and graceful choreography set in motion by a fundamental longing for connection. You are witnessing the first, tender steps in the creation of a star. You are feeling the first stirrings of a galaxy. It all begins here, not with a bang, but with a universal, unifying whisper in the dark. The same presence that holds you gently to your bed, that keeps your feet on the ground, is here, in the beginning, weaving the first threads of the cosmic tapestry, one atom at a time. Section 2, Gathering the Stardust. The whisper continues. Across millions of years, what began as a subtle, almost theoretical suggestion from gravity slowly deepens into a persistent murmur. Those regions of space that were, by chance, just a little richer in matter now begin to draw more definitive boundaries between themselves and the surrounding emptiness. The universe is no longer a perfectly smooth ocean. It is beginning to curdle, to form currents and eddies in its slow, cosmic tide. Let us drift towards one of these regions. From a great distance, it is indistinguishable from the blackness around it. But as you draw closer, over a span of time that defies human experience, you begin to sense its presence. It is a place where the darkness feels a little deeper, a little more absolute. You have arrived at the edge of a great, primordial cloud. Do not picture a cloud in our terrestrial sky, those bright, fluffy ships of water vapor. This is a cloud of a different nature entirely. It is a vast, ethereal structure, a ghost of a thing, stretching for light years in every direction. It is so immense that a beam of light, the fastest thing in the universe, would take a decade, or a century, or even longer, to cross from one side to the other. And yet, it is also a place of profound emptiness. The density here is so low that if you were to cup your hands within it, you would capture only a few stray atoms of hydrogen. It is a vacuum more perfect than any we could ever hope to create on Earth. But it is a vacuum with a purpose. It is a vacuum that is slowly, inexorably becoming less so. Gravity, the patient shepherd, is at work. It is not pulling things in with violence. Instead, it is gently guiding them. An atom that drifts into its sphere of influence does not accelerate wildly, it simply finds its random, chaotic path subtly altered. Its journey becomes a long, languid, spiraling dance, a descent so gradual that it is imperceptible from one millennium to the next. Imagine this cloud as the slow, collective breath of the cosmos. For now, it is an inhalation, drawing in matter from its surroundings atom by atom. The vast majority of this breath is hydrogen, the simplest and most abundant element. But it is not entirely pure. Mingled within this vast sea of hydrogen are traces of helium and something else, something that feels almost solid. It is dust. This is not the dust of an old attic. This is cosmic dust. Tiny, microscopic grains of carbon, silicon, and oxygen. Where did they come from in this young and simple universe? They are the ashes of the very first giants. In the earliest moments after the Big Bang, a few gargantuan, short-lived stars formed and died in spectacular explosions, seeding the void with the first heavier elements. These grains are their legacy. They are like tiny, frozen seeds scattered on the winds of space, and now they too are being gathered by the cloud. These dust grains, as insignificant as they may seem, are crucial. As atoms drift and occasionally bump into one another, they generate a tiny bit of heat, a faint kinetic energy that makes them jittery and resistant to gravity's call. But when an atom collides with one of these cold, microscopic dust grains, it transfers its energy. The dust grain, like a tiny radiator, then sheds that energy away into the void as faint infrared light. This process cools the cloud. It calms the atoms, soothing their frantic energy, making them more receptive to the gentle, gravitational embrace. The dust helps gravity do its work. It makes the gathering more efficient, more inevitable. Let us now drift deep into the heart of this immense, dark nebula. The universe outside vanishes. The faint glow from distant regions of the cosmos is now completely blocked by the sheer volume of gas and dust around you. The darkness is absolute, a velvet blackness that feels ancient and profound. The silence, too, is deeper here. You are in a womb of cosmic potential. And here, in the heart of the cloud, you can finally begin to feel the process in a more tangible way. It is no longer a theoretical drift. It is a flow. All around you, the scattered atoms and dust grains are moving with a shared, almost imperceptible purpose. They are all migrating, ever so slowly, towards a common center. There is no central object yet, nothing to see, but there is a central point of influence. A place where the collective gravitational whisper of the entire cloud is strongest. This is not a river or a wind. The movements are too slow, too gentle. The cloud begins to take on a subtle structure. It is not yet a sphere, but it is no longer formless. It is clumpy. Just as the universe at large began to curdle, so too does the cloud itself. Denser regions within the cloud begin to form their own, smaller centers of gravitational influence. These are the seeds of future stars, the cores of the cloud. They gather matter more quickly than their surroundings, becoming little gravitational whirlpools within the larger, slower current. You are witnessing a process of fractal condensation. A universe of gas gives way to a cloud gives way to clumps, and soon those clumps will give way to something more. This is creation on a galactic scale, and it happens in a state of profound peace. There is no sound, no fury. Just a slow, patient dance of matter and gravity choreographed over millions of years. Every atom is a dancer following the silent music of space-time itself. And the dance floor is this vast, dark, and beautiful cathedral of dust and gas, the birthplace of suns. The great inhalation is nearing its peak, and soon the next phase of creation will begin. Of course, the story continues. Section 3, the slow collapse, a protostar's heartbeat. We leave the panoramic view of the vast, clumpy nebula and drift deeper, choosing one of these denser knots of gas and dust to be our focus. Let us follow its story. This core is still immense by our standards, perhaps a light year or two across, but it is a place with a distinct identity. It has separated from the larger cloud, a self-contained island of potential, destined for its own unique journey. It is a cosmic egg, and within it, something new is beginning to stir. Here, inside this collapsing core, the gentle, inward flow of matter is more pronounced. The whisper of gravity has become a steady, insistent hum. The atoms are closer together now. Not close enough to touch, but close enough that their collective presence is undeniable. The darkness is more profound than ever, a thick, absorbing black. No light can penetrate this dense shroud. No light can yet escape from within. The process of collapse is not a freefall. It is a slow, contested descent. As the atoms of hydrogen and helium are drawn closer together by gravity, they are squeezed. And just as squeezing the air in a pump creates heat, the compression of this gas generates energy. The core begins to warm. It is no longer at the near absolute zero temperature of interstellar space. A faint, primordial warmth is kindling in its heart. This warmth is the cloud's first line of resistance. The heated atoms and molecules move faster, more erratically. They collide more often and more energetically. This outward push of thermal pressure fights back against the inward pull of gravity. For a time, a fragile balance is reached. The collapse pauses and the core simmers in the darkness, a vast, warm, invisible sphere of gas. But gravity is relentless, and the core is still radiating away that heat with the help of those tiny dust grains. The heat leaks out into space as infrared light, a faint and ghostly glow that only our most sensitive instruments could ever detect. As the heat escapes, the outward pressure weakens and gravity once again gains the upper hand. The collapse resumes. It is a cycle of compression, heating, cooling, and further compression. A slow, rhythmic pulsation that takes place over tens of thousands of years. It is the first heartbeat of a star. A slow, deep, powerful rhythm, compress, warm, cool, compress, each beat drawing the core smaller, denser, and hotter. Let us journey now to the very center of this core. We pass through layers of gas that are growing progressively warmer and more compressed. The feeling of being on a gentle slope has become a palpable sense of pressure, of being submerged deep within an ocean of gas. And at the center we find it, the protostar. It is not yet a star. It does not shine with its own light. It is a dense, hot, turbulent sphere of plasma, perhaps the size of our solar system. This is the embryo. Gravity has crushed the gas so intensely here that the atoms have been stripped of their electrons. It is a seething ball of charged particles, glowing not with nuclear fire, but with the raw heat of its own compression. It shines with a dull, cherry-red heat, a light that is immediately absorbed by the thick cocoon of gas and dust still surrounding it. We are inside a furnace, but one that is shrouded from the universe. This protostar is a chaotic and violent place. It is not the serene, stable sun we know. Great plumes of hot gas erupt from its surface, churning and twisting in the darkness. It is also accreting matter at a furious rate. A thick disk of gas and dust is formed around its equator, a swirling vortex of material spiraling inward. This is the accretion disk. It acts like a funnel, channeling the remaining matter from the parent cloud onto the growing protostar. Imagine standing on the edge of this disk. You would see a breathtaking, terrifying sight. A river of gas, wider than 1,000 Earths, flows in a brilliant, incandescent stream from the disk onto the protostar's poles. As this material crashes onto the surface, it creates enormous shockwaves, releasing brilliant flashes of light and heat that are immediately swallowed by the surrounding gloom. The protostar itself is rotating, a legacy of the tiny, random motions of the original cloud. As it shrinks, like a skater pulling in their arms, its rotation speeds up. This spin, combined with powerful magnetic fields generated by the churning plasma, creates something extraordinary. From the north and south poles of the protostar, two colossal jets of matter are blasted out into space. These are the protostellar jets, the infant star's first great exhalation. They are laser-thin beams of superheated gas, traveling at hundreds of kilometers per second. They are the star's way of shedding excess angular momentum, allowing it to continue its collapse. These jets tear through the surrounding nebula like cosmic lances, clearing out vast cavities in the cloud. They are the first visible sign, to a distant observer, that something special is happening deep within the darkness. They are the birth announcement of a star, written in incandescent gas across the canvas of the void. For now, the battle between gravity and pressure continues. The protostar's heart beats on, growing ever hotter, ever denser. The weight of the overlying gas is immense, a pressure beyond all earthly comparison. The core temperature climbs from thousands to tens of thousands to millions of degrees. Gravity is pushing the atoms at the very center into a state of impossible proximity. It is squeezing them, trying to force them to become one again. The stage is being set for the greatest act of cosmic alchemy. The moment of ignition is approaching when this dark, slumbering giant will finally awaken and a new light will be born into the universe. Section 4. Ignition, the first light of stars. We remain deep within the heart of the collapsing cloud, a silent witness at the center of this immense cosmic pressure cooker. The protostar is no longer a slumbering embryo, it is a giant on the verge of waking. The slow, rhythmic heartbeat of its early collapse has quickened the pressure in its core, building to levels that challenge the very laws of physics. We are at a tipping point, a moment of profound transformation. The temperature at the core has now reached an almost unimaginable figure, 10 million degrees. At this temperature, the plasma is not just hot, it is a maelstrom of violent motion. The protons, the nuclei of the hydrogen atoms, are stripped bare of their electrons, and they are moving at incredible speeds, zipping past one another in a frantic, chaotic dance. For all their lives, these protons have been governed by a fundamental force of nature that keeps them apart. Like magnets of the same polarity, they are all positively charged, and they repel each other with a powerful electromagnetic force. This repulsion is what defines the integrity of matter. It is why you do not fall through the floor. It is a fundamental no from the universe. For tens of thousands of years, even as gravity squeezed them closer and closer, this repulsion has held firm. The protons have been forced into the same room, but they have refused to touch. But gravity has one more card to play. It does not crush the electromagnetic force. It simply creates an environment, a crucible of such extreme pressure and temperature that the proton's own frantic energy can overcome it. A new force, one that has been dormant until now, is about to enter the stage. This is the strong nuclear force. It is the most powerful force in the universe, but it operates only over incredibly tiny distances smaller than the proton itself. It is a cosmic glue of unimaginable strength. And now the moment arrives. In the very center of the protostar's core, two protons, driven by the furious heat and pressure, are moving towards each other at a fraction of the speed of light. Their electromagnetic repulsion screams for them to swerve away, as they have done a billion times before. But their momentum is too great. They breach the barrier. They enter that impossibly small domain where the strong nuclear force takes over. And in that instant, everything changes. The two protons are fused together. One of them immediately transforms into a neutron, releasing a positron and a tiny, ghostly particle called a neutrino, which flies out of the star as if it were not even there. The newly formed pair, one proton, one neutron, is called a deuteron. And in this act of fusion, something miraculous happens. The mass of the resulting deuteron is slightly less than the combined mass of the two original protons. A tiny fraction of their matter has not been lost, but converted directly into pure energy, according to the most famous equation in all of physics, E=mc². This burst of energy is released as a gamma ray, a photon of incredibly high energy light. This is it. Nuclear fusion. The ignition of a star. A single fusion event is a tiny thing, releasing a minuscule puff of energy. But it is not a single event. It is a chain reaction. The core is so dense and so hot that this process begins happening everywhere at once. Protons fuse into deuterons. Deuterons fuse with other protons to become helium-3. And helium-3 nuclei fuse together to form the incredibly stable helium-4, releasing even more protons and energy in the process. The core of the protostar has become a nuclear furnace. A wave of light and energy, born from this mass conversion, floods outwards from the core. This is not the gentle warmth of compression anymore. This is a new, ferocious power. It is the light of a sun. This outward rushing tide of energy creates a tremendous new pressure, a radiation pressure that is powerful, constant, and unyielding. And this new pressure finally, decisively, halts gravity's long collapse. The inward crush of gravity and the new outward blast of nuclear fusion meet in a perfect cosmic stalemate. The star finds its equilibrium. It stops shrinking. It stops pulsating. It settles into a state of serene and stable grace that it will maintain for millions, or even billions of years. It has been born. The light that is born in the core does not escape easily. The star's interior is still incredibly dense. A single photon, a gamma ray born from a fusion event, begins a journey that is almost impossible to comprehend. It travels only a fraction of a millimeter before it is absorbed by an atom, then re-emitted in a random direction. It is absorbed again, re-emitted again. Its long journey to the surface is a staggering, random walk. A single photon can take 100,000 years to travel from the core to the surface. Along the way, it loses energy with each collision, transforming from a high-energy gamma ray into thousands of lower-energy photons of X-rays, then ultraviolet, and finally, visible light. And so, after 100,000 years of wandering, the light from that first fusion reaction finally reaches the surface. It bursts forth, and for the first time, the star truly shines. This brilliant, steady light pushes away the last remnants of its dusty cocoon. The protostellar jets falter and die away, replaced by a steady, gentle, stellar wind that flows out in all directions. The dark nebula, which for so long had hidden its secret, is now illuminated from within. The shroud is cast aside, and a new sun announces its presence to the galaxy. It is a beacon of light, a testament to the patient, inexorable power of gravity which took the loneliest atoms in the universe and, through pressure and patience, taught them how to sing. Section 5, Stellar Nurseries and Celestial Families. Our journey now pulls back. We have been intimately focused on the birth of a single star, witnessing its slow, gravitational assembly and its final, brilliant ignition. But this star was not born in isolation. The vast, dark cloud that was its mother did not give birth to a single child. It gave birth to hundreds, perhaps thousands, of siblings all at once. We now zoom out from our newborn sun to see it in its proper context, as a member of a vast and glittering celestial family. You are floating once again in the space that was, not long ago, the dense, dark heart of a molecular cloud. But now it is no longer dark. It is a place of breathtaking beauty and vibrant light. You are inside a stellar nursery, a nebula now aglow with the light of its newborn children. All around you, like diamonds scattered on black velvet, are the newly formed stars. They are a brilliant, dazzling blue-white, a color characteristic of young, hot, massive stars. Their fierce, ultraviolet light illuminates the remaining gas and dust of the parent cloud, creating a spectacular cosmic landscape. This is what astronomers call an open cluster. It is a family of stars all born from the same cloud, all at roughly the same time. They are bound together by their mutual gravity, a shared cradle from which they have all emerged. They drift through space together as a coherent group. Looking at them, you can see a clear family resemblance. They are all made of the same primordial mix of hydrogen and helium, a chemical signature inherited from their parent cloud. The scene is not static. It is a dynamic, evolving environment. The most massive of these newborn stars are cosmic bullies. They burn through their fuel at a prodigious rate, blazing with a light that is tens of thousands of times brighter than that of their smaller siblings. This intense radiation, along with powerful stellar winds, acts like a cosmic sandblaster. It carves and shapes the remaining nebula, pushing the gas and dust away into fantastic pillars, glowing walls, and delicate, wispy filaments. You can see this process unfold before you. Great, cavernous bubbles are being cleared out around the hottest stars, their light revealing the inner structures of the cloud. The edges of these bubbles glow with a furious intensity, a process called ionization. The energetic photons from the hot stars are stripping electrons from the hydrogen atoms in the cloud, causing the gas itself to fluoresce, to shine with a characteristic ruby-red light. This is the beautiful emission nebula, a cosmic canvas painted by the stars themselves. Look closer at the edges of these glowing red walls. You can see dense, dark fingers of dust and gas pointing back towards the hot central stars. These are the famous pillars of creation, structures forged in the crucible of the stellar nursery. They are the densest, most resilient parts of the original cloud, resisting the erosive power of the stellar winds and radiation. But they are fighting a losing battle. The pillars are slowly being evaporated, a process called photoevaporation. The light from the stars is boiling away their surfaces, creating a shimmering, hazy glow around them. And within the tips of these pillars, the next generation of stars is being born. The intense pressure from the light and wind of the massive stars can trigger new waves of collapse in these dense regions. It is a cycle of cosmic birth. The firstborn stars, in their brilliance, trigger the creation of their younger siblings even as they destroy their shared home. Not all the gas and dust is blown away or consumed. Around many of the younger, less massive stars, the accretion disks that fed them during their protostellar phase have survived. These are no longer the violent, incandescent funnels they once were. They have cooled and thinned, settling into vast, stable, rotating platters of gas and dust. We call them protoplanetary disks. Let us drift towards one. It is a dark, spinning silhouette against the bright backdrop of the glowing nebula. From the side, it is a thin, flat line. From above, it is a magnificent spiral, a miniature galaxy in its own right. Within this disk, gravity is still at work, but on a much finer scale. The tiny dust grains, the legacy of ancient, long-dead stars, are beginning to stick together. First, electrostatic forces cause them to clump, forming fluffy aggregates like cosmic dust bunnies. As these clumps grow larger, their own gravity becomes significant. They begin to attract other particles, growing from pebbles to rocks, from rocks to boulders. This is the beginning of planet formation. These growing planetesimals sweep out clear lanes in the disk like a plow clearing a path through snow. You are witnessing the birth of solar systems. Here, in this cosmic nursery, not only are stars being born, but the seeds of future worlds are being planted around them. Each of these glittering points of light is a potential sun, and around many of them, this slow, patient dance of gravitational accretion is beginning anew, building planets, moons, asteroids, and comets from the leftover dust of creation. But this beautiful, tightly knit family will not last forever. The open cluster is gravitationally bound, but only loosely. Over millions of years, the gravitational influence of the galaxy at large, as well as close encounters between the sibling stars themselves, will begin to pull the cluster apart. One by one, the stars will drift away from their siblings, each embarking on its own solitary journey through the vastness of the galaxy. They will carry with them the same chemical fingerprint, a permanent reminder of their shared origins, but they will never again be so close. The nursery will eventually dissolve, its gas and dust scattered to the cosmic winds, ready to one day form a new cloud, a new nursery, and a new generation of stars and worlds. Section 6. The Grand Design, Sculpting a Galaxy. Let us now undertake a journey of scale unlike any before. We have witnessed the birth of a single star, then a family of stars within a glowing nursery. Now, we must pull our perspective back and back and back until the entire stellar cluster we just explored shrinks to a single, glittering point of light. We keep pulling back, past countless other such points, past the dark and empty voids that separate them. We travel for thousands of light years until a new, grander structure begins to reveal itself. You are now floating in the deep, intergalactic space above a vast, swirling island of light. This is a galaxy. A city of stars so immense that it beggars the imagination. It is composed of not thousands, but hundreds of billions of stars, all held together in a celestial dance by their collective, mutual gravity. The star whose birth we witnessed is just one citizen among these countless billions, its personal story absorbed into this larger, grander narrative. From this vantage point, you can appreciate the magnificent architecture of the cosmos. The galaxy is not a random assortment of stars. It has a distinct and beautiful shape. It is a vast, flattened disk of stars, gas, and dust with a bright, dense bulge of older stars at its center. This is a spiral galaxy, one of the most common and elegant forms in the universe. How did this extraordinary structure come to be? The answer, as always, lies with gravity, the patient sculptor, but now working on its grandest canvas yet. Let us rewind the cosmic clock once more, back to a time before this galaxy existed, when this entire region of space was just a colossal, amorphous cloud of hydrogen and helium far larger than any single star-forming nebula. We can think of it as a proto-galaxy, a cloud of clouds. Just as we saw within a single nebula, this protogalactic cloud was not perfectly uniform. It was lumpy, with regions of slightly higher density. And just as before, gravity began to pull these regions together. The very first stars were born within these collapsing clumps, the same process we witnessed earlier, but happening all over this vast volume of space. But there was another crucial factor at play: rotation. The original protogalactic cloud, due to the random motions of all the smaller clouds that merged to create it, had an ever-so-slight, net angular momentum. It was spinning, but so slowly as to be almost immeasurable. As gravity pulled the cloud inward, the principle of conservation of angular momentum took hold. Imagine an ice skater spinning slowly with her arms outstretched. As she pulls her arms in, her spin becomes dramatically faster. The same thing happened to our protogalaxy. As the colossal cloud of gas collapsed under its own gravity, its slow, gentle rotation began to accelerate. The collapse did not happen equally in all directions. The material along the axis of rotation, the North Pole and South Pole of the cloud, could fall directly towards the center without being hindered. This material piled up at the core, forming the dense, spherical central bulge we see today. The stars in this bulge are among the oldest in the galaxy. They formed early in the collapse and are now trapped in looping, elliptical orbits like a swarm of cosmic bees around a central hive. However, for the gas and dust in the plane of rotation, the story was different. As this material tried to fall inward, its increasing rotational speed created a powerful centrifugal force, pushing it outwards. This is the same force that presses you to the side of a spinning carousel. This outward force resisted gravity's inward pull, but only in the equatorial plane. The result was a cosmic compromise. The material could not fall all the way to the center, so instead it settled into stable, circular orbits. Over millions of years, collisions between gas clouds canceled out their random up and down motions, averaging everything out into a single plane. The gas and dust collapsed into a thin, vast, rapidly rotating disk. It is within this disk that the beautiful spiral arms are found, and it is where star formation continues to this day. You can see the evidence of this history in the galaxy's colors. The central bulge has a soft, yellowish-orange glow. This is the light of older, cooler, redder stars. They have been shining for billions of years, and the hot, bright, blue stars that were once among them have long since burned out and died. The bulge is a stellar retirement community. The disk, in contrast, is a vibrant and youthful place. It is awash with the brilliant blue and white light of young, massive stars. It is threaded with the dark lanes of cosmic dust and glows with the telltale ruby red of the hydrogen gas in stellar nurseries. This is where the action is. The disk is a stellar metropolis, constantly recycling gas into new generations of stars, a process that has been ongoing for billions of years. Gravity, therefore, did not just create the stars. It orchestrated them. It took a formless, rotating cloud and, through the simple mechanics of collapse and spin, sorted it into a complex and beautiful structure. It built a dense, ancient city center and a sprawling, vibrant, star-filled suburb. It is the architect of the cosmos, the silent, invisible force that transforms primordial chaos into galactic order. Every star in this vast city of light is following a path dictated by the collective gravity of all the others, a silent cosmic ballet on a scale that transcends our ability to fully grasp. Section 7. The Dance of Spiral Arms. We drift closer now, leaving the panoramic view of the entire galaxy behind, and descend towards its most captivating and enigmatic feature, the great, sweeping spiral arms. From a distance, they look like majestic, painted swirls, as if a cosmic artist had dragged a brush through a spinning canvas of stars. They appear to be solid, permanent structures, great rivers of light flowing from the galactic center. But this is a beautiful illusion. The spiral arms are not solid objects. They are a phenomenon, a pattern, a wave of cosmic traffic. To understand them, we must first understand the motion of the stars themselves. Every star in the galactic disk, including our own sun, is in orbit around the galactic center. But they do not all orbit at the same speed, and they do not orbit like a solid, spinning record. Stars closer to the center complete their orbits much faster than stars further out. This is called differential rotation. If the spiral arms were made of a fixed group of stars, this differential rotation would quickly tear them apart. The inner parts would race ahead, and the outer parts would lag behind, and within a few rotations, the beautiful spiral pattern would be wound up so tightly that it would simply disappear. Since we see elegant, open spirals in countless galaxies, we know something else must be happening. The leading theory is that the spiral arms are density waves. Imagine a highway with a single, slow-moving truck in one lane. As faster cars approach the truck from behind, they must slow down, creating a temporary traffic jam. The density of cars in that section of the highway increases. The cars pass the truck, and then they speed up again, leaving the traffic jam behind. The traffic jam itself, the region of high density, persists and moves slowly down the highway, but the individual cars that make up the jam are constantly changing. The spiral arms are a galactic scale version of this traffic jam. They are regions of slightly higher density that are sweeping slowly through the galactic disk. These density waves are thought to be generated by the gravitational influence of the central bar of stars, or by interactions with smaller, orbiting satellite galaxies. Whatever their cause, they are stable, long-lived patterns that rotate at their own fixed speed, a speed that is different from that of the stars and gas clouds. Let us follow the journey of a single cloud of gas as it encounters one of these arms. As the cloud, in its normal orbit, catches up to the slow-moving spiral arm from behind, it enters a region of higher gravitational pull. The density wave, with its slightly greater concentration of stars and gas, gives the cloud an extra gravitational squeeze. This compression is the key. It is precisely the trigger needed to kickstart the process of star formation we witnessed earlier. As the gas cloud is squeezed by the density wave, it begins to collapse, forming the dense cores that will become stellar nurseries. The cloud, once dark and quiescent, now lights up with the birth of brilliant, new, blue stars. This is why the spiral arms are so bright and well-defined. They are not bright because they contain more stars overall, but because they contain all the young, hot, and incredibly luminous stars. They are the galactic-scale stellar nurseries. The spiral arms are, quite literally, the crest of a wave of star birth sweeping through the galaxy. You can see the story written in the arm itself. On the inner, trailing edge of the arm, the side the gas clouds enter first, you can see the dark, dusty lanes. These are the molecular clouds, just beginning to be compressed. As you move across the arm, you see the brilliant blue-white glow of the newly formed open clusters, the families of hot, young stars that have just ignited and blown away their dusty cocoons. Further still, on the outer, leading edge of the arm, you see the red glow of the emission nebulae, the glowing hydrogen gas being eroded by the newborn stars. And what happens after a star is born in the arm? The star continues its own, faster orbit. It moves through the density wave and emerges out the other side, into the less dense region between the arms. The star is now free of the traffic jam. The most massive and brilliant of these blue stars have very short lives. They are born in the arm, shine with incredible ferocity as they travel through it, and then, shortly after leaving the arm, they die in spectacular supernova explosions. They live and die so quickly that they never get very far from their birthplace. This is why the arms are so prominent. They are decorated with these fleeting, luminous jewels. Smaller stars, like our own sun, have much longer lives. They too are born within a spiral arm. Our sun was likely born in an arm and has since passed through several more during its 5 billion-year life. It emerges from the arm and spends hundreds of millions of years drifting through the relatively quiet, darker space between the arms, before eventually catching up to the next arm in its path, where the cycle of cosmic scenery begins anew. So, the spiral arms are not a place but a process. They are a slow, graceful, self-perpetuating dance of gravity, compression, and creation. They are a gravitational echo, a cosmic ripple that triggers the continuous renewal of the galaxy, ensuring that new stars and new worlds are always being forged from the ancient dust. They are the living, breathing pulse of the galactic city. Section 8. The Silent Anchor, Supermassive Black Holes. Our journey now takes us to the most extreme, the most mysterious, and the most powerful place in the entire galaxy. We leave the gentle, luminous dance of the spiral arms and begin a long, inward flight towards the very heart of the stellar city. As we travel, the density of stars increases dramatically. The soft, dark spaces between them shrink and disappear, replaced by a continuous, overwhelming blaze of light. We are approaching the galactic bulge, the ancient, crowded core we observed from afar. The stars here are old and golden, packed together in a swarm of incredible density. Their orbits are no longer the calm, circular paths of the disk, but a chaotic fizz of elliptical trajectories, looping high above and below the galactic plane. The collective light is so intense that the concept of night has no meaning here. It is a place of eternal, brilliant day. As we push deeper towards the absolute center, something strange begins to happen. The motions of the stars become faster and more frantic. We are observing stars' great, massive suns whipping around an unseen point in space at astonishing speeds. One star, known to astronomers as S2, completes a full orbit in just 16 years, reaching speeds of over 8,000 kilometers per second at its closest approach. To move this fast, it must be orbiting something of truly colossal mass, something that exerts a gravitational pull of unimaginable power. And yet, when we look at the point they are all orbiting, we see nothing. There is no great central star. There is no cluster of suns. There is only an unnerving, perfect blackness. We have arrived at the galaxy's ultimate secret, its silent, invisible anchor. We have arrived at Sagittarius A, pronounced A star, the supermassive black hole at the center of our Milky Way. Let us pause and consider what this object is. It is not an object in the conventional sense. It is a region of spacetime so warped and twisted by gravity that nothing, not even light, can escape it. It is the endpoint of gravitational collapse, a place where the density is, as far as our physics can tell, infinite. All the matter that has fallen into its mass of 4 million suns, in the case of our galaxy, is crushed into a point of zero volume called a singularity. The blackness we see is the event horizon. This is not a physical surface. It is a point of no return. Imagine it as a waterfall in the river of spacetime. Once you cross its edge, the current is too strong, and you can only go one way down. Anything that crosses the event horizon, a star, a cloud of gas, a beam of light, is irrevocably lost to our universe, its mass added to the black hole's own. The size of this event horizon for Sagittarius A is surprisingly small, only about 30 times the diameter of our Sun. 4 million solar masses, packed into a space that could fit comfortably inside the orbit of Mercury. For a long time, these central behemoths were thought of as purely destructive monsters, cosmic vacuum cleaners devouring everything in their path. And while they certainly are dangerous to anything that strays too close, we now understand their role as something far more fundamental and creative. The supermassive black hole is not just a resident of the galaxy. It is a crucial part of its formation and evolution. It is the galaxy's gravitational anchor. In the very early universe, the seeds of these black holes likely formed from the collapse of the very first gargantuan stars, or from the direct collapse of massive clouds of gas. As the proto-galaxy began to take shape, these seed black holes sank to the gravitational center. There, they feasted, growing by consuming gas and by merging with other black holes. A fascinating relationship emerged. The galaxy and its central black hole grew up together, in a process of coevolution. The more gas the galaxy gathered, the more the black hole could feed and grow. But the black hole also fed back into the galaxy. As material spirals into the black hole through its accretion disk, it becomes superheated, creating one of the most energetic phenomena in the universe: an active galactic nucleus, or quasar. The light from this accretion disk can outshine the entire galaxy of 100 billion stars combined. The process also launches powerful jets of energy, similar to the protostellar jets we saw earlier, but on a scale that is millions of times larger and more powerful. These jets blast out from the galactic core, pumping tremendous energy into the surrounding gas. This feedback acts as a galactic thermostat. If too much cold gas flows towards the center, the black hole turns on, heating and blasting the gas away, which temporarily shuts down star formation in the bulge. This prevents the galaxy from forming stars too quickly and burning out. When the gas cools and begins to fall inward again, the cycle may repeat. The black hole regulates the galaxy's metabolism, ensuring it has a long and stable life. Our own Milky Way's black hole is currently quiet, in a state of slumber. It is only snacking on a thin trickle of interstellar gas. But the frantic orbits of the stars around it are a permanent testament to its power, a silent reminder of the anchor that holds our entire galactic city in its gravitational thrall. It is the silent king, the invisible heart, whose immense gravity provides the ultimate pivot point for the grand, celestial dance of 100 billion suns. It is the ultimate expression of gravity's power, to create not just a star, but a point of such density that it becomes the axle for an entire island universe. Section 9. Galactic Mergers. A Cosmic Embrace. Having explored the inner workings of our own galactic island, we now pull our perspective back once more, returning to the deep, dark void of intergalactic space. Our galaxy, the Milky Way, is not alone in this vastness. It is part of a small, gravitationally bound collection of about 50 galaxies known as the local group. And across the cosmos, galaxies are gathered into groups, clusters, and superclusters, all tracing the invisible lines of gravitational influence. Gravity, the force that gathers atoms into stars and stars into galaxies, does not stop at the galactic edge. Its reach is infinite, and so, just as stars within a galaxy orbit a common center, galaxies themselves are in motion relative to one another, their paths dictated by the gravitational pull of their neighbors. Sometimes, these paths lead to one of the most spectacular and creative events in the entire universe: a galactic merger. Let us journey forward in time and space to witness such an event. We see two spiral galaxies much like our own on a collision course. They have been dancing around each other for 1 billion years, their mutual gravity pulling them into a long, slow, graceful spiral. This is not a collision in the earthly sense of a violent, destructive crash. Galaxies are mostly empty space. When they merge, individual stars do not smash into each other. The odds of a direct stellar collision are infinitesimally small. Instead, it is a collision of gravitational fields. It is a slow, majestic, and transformative embrace. As the two galaxies first begin to pass through each other, their structures are warped and distorted. The neat, flat disks are twisted and pulled. Great, sweeping tails of stars and gas are drawn out from the galaxies by tidal forces, like streamers in a cosmic wind. These tidal tails can stretch for hundreds of thousands of light years, creating luminous bridges and arcs in the darkness between the galaxies. They are a beautiful, temporary record of the gravitational chaos. Inside these tidal tails, the drama of star birth is reenacted on a grand scale. The gas that was once peacefully orbiting within the galactic disks is now violently compressed and shocked as the galaxies interpenetrate. This triggers a furious burst of star formation, a starburst. The merging galaxies light up with the brilliant blue light of millions of newborn stars. Great knots of stellar nurseries form along the tidal tails and in the chaotic, churning interface between the two disks. For a time, the merging system can become one of the most luminous objects in the local universe. The two supermassive black holes, one from the core of each galaxy, begin their own inexorable dance. They sink towards the center of the newly combined mass, shedding their orbital energy by flinging away nearby stars. They orbit each other, getting closer and closer in a spiral that could last for millions of years. Eventually, they will merge, coalescing into a single, more massive black hole, sending a powerful burst of gravitational waves ripples in the fabric of space-time itself out across the cosmos. After the initial chaotic pass-through, the galaxy's momentum carries them apart again. But they are gravitationally captured. They cannot escape. They slow down, stop, and are drawn back together for a second encounter. This process may repeat several times, a great cosmic oscillation. With each pass, they lose energy, and their structures become more and more entangled. The beautiful, orderly spiral arms are completely destroyed, their stars scattered and randomized. The disks are puffed up, their kinetic energy converted into the random, chaotic motions of a stellar swarm. Over a period of about 1 billion years, the two galaxies will fully merge. The dance will end. The chaos will subside. And what is left is something entirely new. The two spiral galaxies are gone, and in their place is a single, massive, and very different type of galaxy. An elliptical galaxy. Elliptical galaxies are vast, spheroidal collections of stars, looking like giant, fuzzy cosmic footballs. They lack the flat disks and spiral arms of their predecessors. They are composed almost entirely of older, redder stars, moving on random elliptical orbits. The great starburst triggered by the merger has used up most of the available gas, and the remaining gas has been heated and puffed up, unable to cool and form new stars. The galaxy has settled into a long, quiet retirement. This process is a fundamental engine of cosmic evolution. The largest galaxies in the universe, the giant ellipticals that sit at the hearts of massive galaxy clusters, are believed to have been built up through a long history of such mergers. Gravity, in its relentless quest to bring things together, operates on every scale. It forges stars from dust, arranges them into spiral galaxies, and then, in its grandest act of creation, it merges those galaxies into even larger cosmic structures. And this story is not just an astronomical curiosity. It is our own future. Our Milky Way is currently on a collision course with our nearest large neighbor, the Andromeda Galaxy. In about 4.5 billion years, our distant descendants, should they exist, will have a sky filled with the breathtaking sight of the Andromeda Galaxy stretching from horizon to horizon. They will witness the slow, graceful, and ultimately transformative embrace as two great stellar cities become one, a final, spectacular testament to the patient, persistent, and creative power of gravity. Section 10. The Cosmic Web, our final destination. Our journey is nearing its end. We have traveled from the loneliest hydrogen atom in the primordial dark to the fiery heart of a newborn star. We have seen families of stars ignite within glowing nurseries, and watched as gravity sculpted them into a magnificent spiral galaxy, anchored by a silent, supermassive black hole. We have even witnessed the slow, cosmic embrace of two galaxies merging into one. Now, for our final act, we must undertake the largest leap of scale possible. We must pull back from the merging galaxies, past the local group, past neighboring superclusters, until individual galaxies are but faint smudges of light, and the entire observable universe comes into view. From this ultimate vantage point, you see the grandest and most profound structure that gravity has built. The universe is not a random scattering of galaxies in the void. It has a structure, a celestial architecture of breathtaking scale and complexity. You are looking at the cosmic web. It is a delicate, luminous filigree that stretches across the entirety of space. It looks almost organic, like the neural network of a cosmic brain or the intricate structure of a sponge. There are vast, near-empty regions, bubbles of profound darkness known as voids. These are the great deserts of the cosmos, places where the initial density of matter was slightly lower than average, and from which gravity has shepherded almost everything away. Stretching between these voids are long, winding filaments of galaxies, like shining threads of silk. These filaments are the great highways of the universe, channels along which matter and galaxies flow. They trace the densest regions of the primordial universe, the places where gravity's whisper was strongest from the very beginning. The galaxies are strung along these filaments like pearls on a necklace, each one a city of light in the vast, intergalactic country. And where these filaments cross, where the great cosmic highways intersect, we find the brightest, most massive structures in the universe, the galaxy clusters. These are the great metropolises of the cosmos, sprawling collections of hundreds or even thousands of galaxies, all bound together in a deep, shared gravity well. They are filled with a searingly hot gas and dominated by the giant elliptical galaxies forged from countless mergers. These nodes are the gravitational focal points of the entire cosmic structure. This web is the skeleton of the universe, and its architect was gravity. The same gentle, persistent force that pulled two atoms together also orchestrated this colossal structure over 13.8 billion years. It is a testament to a simple rule, applied relentlessly over cosmic time. Matter attracts matter. The rich get richer. The slightly denser regions of the early universe pulled in more and more material, growing into the filaments and clusters we see today, while the less dense regions were emptied out, becoming the voids. But there is a final, humbling layer to this story. The luminous matter we see, the stars, the gas, the galaxies that trace this beautiful web is only a tiny fraction of what is actually there. All of this visible matter is like a dusting of snow on a much larger, invisible mountain range. The vast majority of the mass in the universe, about 85% of it, is something we cannot see. We call it dark matter. We do not know what dark matter is, but we can feel its presence. We see its gravitational effects everywhere. It is the extra mass that keeps stars orbiting faster than they should in the outer parts of galaxies. It is the gravitational lens that bends the light of distant objects. And most importantly, it is the invisible scaffolding upon which the cosmic web is built. It was the gravity of this mysterious dark matter that formed the initial web structure. The ordinary matter we know and love, the hydrogen and helium of the early universe, was then drawn into these pre-existing dark matter halos, like water flowing into a network of invisible riverbeds. It was only then, once concentrated by the gravity of the dark matter, that the ordinary matter could cool, condense, and finally form the stars and galaxies we see. The luminous universe is just the decoration on an immense, invisible structure of dark matter. And so our journey ends here, floating in the presence of this grand, silent, and mysterious cosmic web. We have seen how a single fundamental presensa gravitica can take a smooth, simple universe and, over billions of years, build a reality of astonishing complexity and beauty. From the gentle whisper that gathered the first atoms, to the furious pressure that ignited suns, from the celestial dance that shaped spiral arms, to the slow embrace that merges galaxies, and finally, to the vast, invisible scaffolding that holds the entire cosmos together. It is all one continuous story, the story of gravity's patient, creative, and unending work. And you, as you lie here, are not separate from this story. The calcium in your bones, the iron in your blood, the carbon in your cells, these heavier elements were forged in the hearts of stars that lived and died long ago. Those stars were born in a nebula which was part of a galaxy, which is a node in this cosmic web. The very atoms that make you are a piece of this cosmic history. The same gentle force of gravity that holds you to your bed is the very same force that built the stars. You are, in the most literal sense, a child of the cosmos, connected by an unbroken chain of events and a single universal force to everything you have just seen. Now let your mind drift. Let these cosmic thoughts dissolve into the quiet of the night. Feel the gentle, steady pull of the earth beneath you, a local echo of that same universal presence that shapes the galaxies. It holds you safe, keeps you grounded. The universe is vast and wondrous, but tonight, your universe is here, in this peaceful space, in this moment of rest. Allow the journey to fade, leaving only a sense of connection and calm. Sleep well, and may your dreams be filled with silent, shining stars.